Students, in this class we are going to find the area bounded by the lines 5x negative 2y equal to 15 and x positive y positive 4 equal to 0 and the x-axis. So what we got to do is we will have to find the point of intersection for line 1 and line 2. Okay, so let me place the lines. 5x negative 2y is equal to 15 and x positive y is equal to negative 4. This is 1 and this is 2. Now we have to solve this. So what I'm going to do to solve this, I'm going to multiply line 2 by 5 and line 1 just by 1. So that's going to be 5x negative 2y is equal to 15 and 5x positive 5y is equal to negative 20. So you solve them, change the signs, and this will become negative, this will become positive. The 5x will be cancelled. You have negative 2y, negative 5y, that's negative 7y. This is positive 15 and positive 20, that will become 35. So y will be 35 divided by negative 7, which is negative 5. So this is the value of y. Now substitute y equals negative 5 in 1. So we have got 1 to be as 5x negative 2 times y is negative 5 is equal to 15. So this is going to be equal to 5x positive 10 is equal to 15. Move this, you get 15 negative 10, which is 5. 5x is equal to 5, x is equal to 5 over 5, which means the value of x is equal to 1. So therefore the point of intersection for the lines is 1 comma negative 5. So that will be, so if you were to draw the axis, this is x-axis, this is y-axis. So 1, x is 1 here, and negative 5, negative 1, negative 2, negative 3, negative 4. Say, let us imagine this is the point. So this point will be the point of intersection of the two lines. Now we got to draw the lines, right? So this is 5x negative 2y is equal to 15. I want to know where they cut at x-axis. So you have to find the x-intercept. To get the x-intercept, put y is equal to 0. So that would give you 5x is equal to 15. So x will be equal to 3 here. So 3 comma 0. So if you have, this is 1, this is 2, and this is 3. If I were to take this as 3 comma 0, then you got a line like this, okay, hitting the x-axis at 3 comma 0. So take the second line. The second line is x positive y is equal to negative 4. You substitute y is equal to 0. You get x is equal to negative 4. So the next line would be over here, negative 4 comma 0. So if you were to draw the line will be hitting the intersecting point over here. So the intersecting point, I want to write it down, 1 comma negative 5, and this line is x positive y is equal to negative 4, and this line is 5x negative 2y is equal to 15. So you have to find this region, okay, find this region, because this is the region obtained by the intersection of two lines and the x-axis. You have the x-axis over here, okay, so you have to obtain this region. So the required area that we are looking for is integral negative 4 to 1 negative 4 negative x times dx, followed by integral 1 to 3 5x negative 15 divided by 2 times dx. Now why have I placed the modulus sign? Because the region is actually on the negative side. So now integrating, so I'm going to be considering integral negative 4 to 1 negative 4 negative x times dx. When you integrate this, you get negative 4 times x negative x squared divided by 2. The limits are negative 4 to 1. So you substitute the upper limit, you get 4 of 1, negative 1 squared divided by 2. This is for the upper limit, followed by the lower limit, negative 4 of negative 4, negative 4 squared divided by 2. So this is equal to negative 4, this is 1 over 2, negative sign, negative times negative is positive, 4 times 4 is 16, this is 16 there with a negative sign, so 16 divided by 2. I can rewrite this taking 2 as the LCM, so negative 8, negative 1, and followed by a negative sign. This 2 divides 16 8 times, so you got 16, negative 8, so this is going to be negative 9 divided by 2, followed by negative 16, negative 8 would give me 8, so you take the LCM as 2 there, this will become negative 9, negative 16, which is negative 25 divided by 2. So therefore, the modulus of negative 4 to 1, negative 4, negative x times dx will be mod of negative 25 over 2, which is 25 divided by 2 square units. Okay, this is for part 1. Okay, this is the first part, and you have to do it for the second part. So consider integral 1 to 3 5x negative 15 divided by 2 times dx. Okay, so this is going to be equal to 5x squared divided by 2 negative 15x divided by 2. I can rewrite this as 1 over 2 times 5x squared negative 15x. The limits are 1 to 3. So applying the limits is going to be 1 over 2. I apply the upper limit, 5 of 3 squared negative 15 of 3, okay, followed by a negative sign. Lower limit, 5 of 1 squared negative 15 of 1. Okay, so parenthesis, so this is equal to 1 over 2 times 3 squared is 9, 9 times 5 is 45, negative 15 times 3, that's 45, followed by negative sign. So 5 negative 15, this gets cancelled, so 1 over 2 times negative 5 negative 15 will give me 10, so that's going to be negative 10. Negative times negative will become positive, so it's going to be positive 10. 10 divided by 2 will give me 5. So this is for part 2, right? Now part 1 added with part 2, so that's going to be, part 1 is 25 over 2 positive 5, so you take the LCM as 2, so this will become 25 positive 10 divided by 2, which is 35 divided by 2. So the final answer, so therefore the required area is 35 divided by 2 square units. You need to write that. So this is the final answer to the question.